topic we'll be discussing in this lecture is snooping TCP. So basically snooping TCP is an advancement of ITCP, indirect TCP. One of the drawbacks of indirect TCP is the segmentation of single TCP connection into two TCP connections. Because of that, the original end-to-end TCP semantics was lost. Whereas ITCP is an enhanced version of indirect TCP which works completely transparently and leaves the TCP end-to-end connection intact. Okay. So it's more transparent in the sense that in indirect TCP, the acknowledgement will be sent by the foreign agent before the packet reaches the destination. But that will not happen in case of snooping TCP. Okay. So the main function of the enhancement is to, so basically this also works in the same way. Here the foreign agent buffers the data. Here's the foreign agent buffers the data for, here the foreign agent buffers the data for all communication from the mobile host to the correspondent node and also from the correspondent node to the mobile node. Okay. So the foreign agent buffers all packets. Okay. First let us and also the foreign agent performs snooping. The foreign agent also performs snooping. The snooping was done to recognize acknowledgements in the in both the directions. Okay. Snooping was done to recognize acknowledgements in both the directions. If the acknowledgement was missing, then the foreign agent itself will do the retransmission. If the acknowledgement is missing, then the foreign agent itself will do the retransmission. But it won't send acknowledgements. But it won't send any acknowledgements. Acknowledgements will be sent only by the respective destination. When the communication is from the correspondent node to the mobile host, the mobile node only will send the acknowledgement. Similarly, when the communication is from the mobile node to correspondent node, the correspondent node only will send the acknowledgement. But foreign agent, what it will do in the sense, it will buffer all the packets. Suppose if any of the acknowledgement is missing, and if that it will snoop whether the acknowledgement, all acknowledgement is going properly in both the directions or not. If acknowledgement is missing, then it will not wait for the respective destination node to send the retransmit, and rather foreign agent itself will retransmit, so that the retransmission will be done in a faster way. Okay. So first let us understand how the communication happens from, let us understand how the communication happens from foreign agent, how the communication happens from correspondent node to the mobile node. Okay. So data transfer to the mobile node, how it happens. So the foreign agent buffers data. The foreign agent will buffer all data that were transmitted from the mobile host to the so here we are discussing the communication from the correspondent node to the mobile node. So the foreign agent buffers all data that were transmitted from the correspondent node to the mobile node until it receives the acknowledgement of the mobile host or the mobile node. And the foreign agent detects packet loss via duplicate acknowledgements or timeout. Whenever there is a timeout or whenever there is a duplicate acknowledgement, the foreign agent will understand there is a packet loss. Okay. And whenever there is a packet loss, the foreign agent itself will retransmit those. Okay. So it will perform fast retransmission wherever fast retransmission is possible. And so this is similar for the, so like how it will done in the fixed network, like that it will perform the a fast retransmission. Similarly, when you take the other way, whenever there is a data transfer from the mobile host to the correspondent host, the FA detects loss on the wireless link via sequence numbers. Again, the same thing. It will actually buffer the packet, and if there is any packet loss, it will identify through the missing acknowledgements, and FA answers directly with negative acknowledgement. Okay, so whenever there is a packet loss, uh, uh, if there is a packet loss in the wireless links, then the packet it will identify the missing packet through the sequence number. Okay, then FA immediately answers with the negative acknowledgement. Say suppose after packet 1, packet 3 is coming instead of packet 2, then it means that packet 2 was lost in the wireless link, because here the communication is from the mobile node to correspondent host, but in between the foreign agent is snooping, and foreign agent identifies that packet 1 is coming, after that packet 3 is coming, so packet 2 is missing, so it sends a negative acknowledgement for packet 2. Okay, mobile host can now retransmit data with only a shorter delay, because you've got to know that there is a missing before the packet reaches the correspondent node. So MAC layer often has similar mechanisms to those of TCP. Thus, the MAC layer can already detect duplicated packets due to retransmission and discard them. So this can be integrated in the MAC layer also. So the problem with the snooping TCP is snooping TCP does not isolate the wireless link as good as indirect TCP. Okay, this is the disadvantage of TCP, snooping TCP. The main advantage of snooping TCP is the end-to-end TCP semantic is preserved. Okay, it maintains the end-to-end TCP semantics. I think it is clear. So whenever there is a communication from the correspondent node to the mobile host, the foreign agent snoops the packet flow to recognize acknowledgements. Okay, and it also buffers the packet towards the mobile node. That is, whatever the data that is transmitted from correspondent node to mobile node, it will be it will be buffered. Okay, and it performs local retransmission, and it performs local retransmission. So let us see this diagram, and it performs it buffers all the packet from correspondent node to for mobile host, and whenever there is a missing acknowledgement, it performs local retransmission. It performs local retransmission in case of packet loss on the wireless link. Okay. The foreign agent buffers every packet until it receives an acknowledgement from the mobile host. If the foreign agent does not receive an acknowledgement from the mobile host within a certain amount of time, either the packet or the acknowledgement has been lost. Okay. Alternatively, the foreign agent could receive a duplicate acknowledgement which also shows the loss of packet. Now the foreign agent retransmits the packet directly from the buffer. So it performs a faster retransmission compared to the correspondent host. Okay. Similarly, for data transfer from the mobile host to the correspondent host, the foreign agent snoops into the packet stream to detect gaps in the sequence numbers of the packet. So when there is uh, when if it detects any missing packet, as I said already, after packet 1, if packet 5 comes, then it will understand that packet 2, 3, 4 are missing. Okay, so whenever there is a missing packet, it will send negative acknowledgement to the mobile host. The mobile host can now retransmit the missing packet immediately, uh, but reordering will be done at the corresponding host end. Okay, so this is how the snooping TCP works. Its advantage is it maintains the end-to-end semantics, and its major disadvantage is that the snooping TCP does not isolate the wireless link as good as other approaches. And another drawback with snooping TCP is if end-to-end encryptions were applied, then you cannot perform snooping. Then the entire effort that has been spent in buffering and snooping, that will all go waste. Okay, because you cannot snoop on the encrypted packet, and you cannot know whether it is an acknowledgement packet or what packet or what, all those things cannot be understood. Okay, or whether it is an what is the sequence number, all these cannot be seen. Okay, so in future, most of the communication will be an encrypted communication. So in that case, the implementation of this scheme will become difficult. Right? So, so this is how snooping TCP works, right? So that's it about this particular concept. Let us stop here. Thank you.